来的场次，我们非常荣幸邀请到演讲嘉宾 Dow Company Director for R&D and Technical Service Asia Pacific Myra Zai 博士。Myra Zai 博士将为我们带来题为 AI 世代的数据中心冷却技术的精彩分享。For our next session, it is our great honor to welcome our speaker, Dr. Myra Zai, Director for R&D and Technical Service Asia Pacific. Dr. Myra Zai will share her insights titled Cooling AI Generation Data Centers. Ladies and gentlemen, please welcome Dr. Myra Zai.
Good afternoon, everyone. It's a real pleasure to be here at Computex. Today, I'm going to share with you a topic that is, how should I say, extremely hot right now. Not hot like the latest launch GPU, hot like if we do not manage it well, the performance, the reliability, and the operating cost all start melting down. Yes, I'm going to talk about cooling. As a researcher who has been working in chemical industry for more than 20 years, it's exciting to share with you how material science enable AI infrastructure and data center. A little bit about our company. Dow, for past 128 years, has been innovatively applying chemistry and engineering into real-world problems to address the sustainability and performance across a wide range of market segments: consumer, energy, and industry like electronics, semiconductor, and heat management. Our purpose is to deliver a sustainable future with our material science expertise and collaboration with our partners. So we bring that purpose into life by enabling technologies that make our modern infrastructure, like a data center, safer, more reliable, and more efficient. Let's switch the gear to AI and data center. We're at a defining moment with the evolution of computing. During past decades, we have pushed silicon further than many thought possible. However, today, AI has changed the equation completely. We are relying more AI apps, more complicated tasks. We are giving AI to expect it deliver intelligence for us. So the AI workload is growing exponentially. The power density rises dramatically. And the system is hitting performance bottleneck because of heat. We have seen air cooling is reaching its limit, and liquid cooling become essential. During previous several sessions, we have learned that the power consumption of data center is massive. Actually, industry analyst has predicted that by 2030, the consumption of electricity of AI infrastructure is going to double by 2030 versus 2025. That's equal to annual growth rate of 18%, driven by AI adoption, edge computing, and digitalization transition across all the industries. So the question we need to answer is, how do we sustain AI growth without breaking the energy system behind it? And you might be wondering, what electricity go within a data center? The largest part goes to IT equipment. The server, the storage system, the internet gear, which account for averagely 50% of energy consumption. And then it comes to cooling system. It can go range from 30 to 40%. For high-density AI data center, it can go up to 50%. We do need cooling system to help all the IT equipment running at the optimum temperature to prevent equipment failure. And the last part is other IT infrastructure, like UPS. That's only 10%. With IT equipment efficiency improves, the cooling share has become more visible. It can easily go up more than 40%. So cooling is no longer the supporting function of the whole system. It has become the core enabler of AI computing. So comparing with AI, with all the IT equipment, cooling seems not that complicated. Yes, fundamentally, it's simple. It's just two processes of heat transfer and heat transport. For AI, similar to process, two steps to manage it. The server generates a lot of heat. We need to remove the heat from the chip to the cooling hardware. That's the material team does. I will share with you more about team later on. And then you need to remove that heat out of the system. That's the material coolant does for liquid cooling. So the coolant flows through the cold plate, absorbs heat, and carries the heat away to the heat exchanger or facility loop. So teams and coolant work together as two critical material to help with the system cooling process. Teams enable efficient heat transfer at the chip and module level, and coolant enables reliable heat transfer across the system. So think about teams like a bridge that moves the heat out of the chip, and coolant is the highway carries the heat away. And let's talk about team for heat transfer. Why we need team? Thermal interface material. Because for two solid surface, even very flat, when you look at it from your naked eyes, they connect very well. However, under microscopic level, they only connect at peaks. There are a lot of micro gaps in between, filled with air. Air is a great insulator. So we do need team fill into that air to create efficient airflow. So the goal of team is very simple. Get the heat rapidly and reliably transfer out. However, the challenge is not simple. It's actually pretty complicated. Think about the team is like the handshake between silicon with the rest of the world. If your handshake is weak, the relationship does not last. If your handshake is messy, the manufacturing does not last. If your handshake traps airs, performance does not last. So the team material must balance thermal conductivity, conformability, mechanical stability, and processability. As a global material science leader with deep expertise in silicon material, for more than 80 years, we have built decades of innovation in thermal interface material. And leveraging this foundation, Dow has developed a scalable, fully silicon team platforms, including the gel, grease, and gum technology, engineered to address diverse interface conditions across chip and module level. Each material family is designed to optimize thermal performance, long-term stability, and manufacturability in next-generation computing and data center applications. Thermal grease help deliver ultra-low thermal resistance with long-term stability, which has been widely proven in CPU and GPU platforms. Thermal gel provides strong gap fillings with low autogassing and low contamination risk, validated in sensitive applications like optical transceivers. And some gum balance thermal performance with control tech, revocable and robust under vibration, proved in our module power modules. So here we are not just pushing thermal conductivity. We optimize reliability at scale. As we all know in AI infrastructure, performance is not a one-day benchmark. It is many years contract with our customers. So we are super proud that our Dowseo team materials has been equipped in most of the data center systems. And we are innovating with more than 80% of optical transceiver makers for heat management solutions. After finishing the heat transfer, we need to deal with the heat transport. We all agree that the cooling has been shifting from air cooling to liquid cooling. Liquid cooling actually is not only about more capacity. It is enabling higher rack density. It's improving energy efficiency and delivering more predictable thermal controls. And at Dow, we offer both direct-to-chip and immersion cooling technology. For direct-to-chip, with both primary loop and secondary loop solutions. During the shift from air cooling to liquid cooling, we have heard a consistent message from our customers. They asked, will the coolant corrode my pipe over time? How about leakage? And ultimately, could I trust your coolant running in my system 24 hours a day, 7 days per week, without any surprise? As we all know in this industry, downtime is not just inconvenience. It is very expensive. And at Dow, actually, we have been working with heat transfer fluids for close to 1 century in different industries. So this is not new territory for us. Leverage that experience, we have developed Dow Frost with dedicated inhibitor package and tailor-made it for data center applications. And we use pharmaceutical-grade propylene glycol. Yes, that's the level of purity you are going to expect with your medicine. And Dow actually produced that pharmaceutical-grade propylene glycol by ourselves. We are the largest propylene glycol producer at the world. And it's nice to know that your coolant will get the premium care from the pharmaceutical level of propylene glycol as a base fluids. And by combining this high purity propylene glycol and the additive package, Dow Frost provide excellent protection against corrosion and microbial growth to ensure safe and stable operation, even under high loading conditions for decades. And let's talk about immersion cooling. Immersion cooling is a very powerful architecture. This is where material science matters again. As immersion cooling is not just a fluid, it's a fluid that needs to coexist with a polymer, with a rubber, with a metal, with very complicated electronic assemblies, and under very high duty cycles. So our fluids has been developed, have very good chemical resistance, and can tolerate a high temperature, and non-hazard and non-flammable, and most importantly, with reduced environmental impact, including low global warming potential and zero ozone depletion potential. And our Dow Seal immersion cooling fluids have been used in edge computing applications. Of course, performance is critical. Supply matters just as much. Dow, as I mentioned, is the top leader of propylene glycol manufacturer and also silicon materials. So we are fully back integrated. We have the plants across global in all the key regions. Take the example of Dow Frost. There are 4 manufacturing sites in United States, Europe, and 2 sites in Asia Pacific. So when we say stable supply, we do not mean we will try our best. We mean you can count on us. So with the high performance, low maintenance cost, and stable supply, Dow Frost has been preferred solution for many of our customers. As OCP recognized solution provider, the cooling fluids has passed stringent validation from both global and local customers, and has been deployed widely globally at scale. When I mention at scale, it means 7 gigawatts. So Dow has been the top leader of liquid cooling solution. 7 gigawatts tell us 3 important things. The performance is validated, the supply chain is proven, and that we have real operation experience, which means less risk, and a lot of confidence. As we know, when our customer buy our products, it's not only the product itself. They buy the confidence in standard, the confidence in stable supply, confidence in life cycle support. As more and more data center build up, our customers are facing the problems of system management. As the reality we are facing today is the sampling and testing methods are very fragmented, and service providers are not always coordinated. Sometimes accountability can be unclear. So here, we launched Dow Coolant Care Network. We integrate the sampling, testing, and expert analysis in professional interpretation and suggestions for mitigation plan together. Dow serves as technical link between lab, service provider, and our end user. So it helps reduce the fragmentation in cooling solution management, improve decision making, and lower operational risk. Think it like our coolant solution, like the healthcare system for people. You monitor early, you track the trend, and you prevent problems Because in modern data center, our coolant is not just a consumable, it's a managed system. And Dow integrates this model to help and support industry's next phase of growth to help customer with the TCO. I would like to introduce you another very unique capability for Dow. We call it Cooling Science Studio. This is where Dow collaborates with our customer for next generation product development. Please allow me to show you the video first.
In the era of intelligence, the stronger the computing power, the greater the thermal challenges. Overheating is increasingly limiting the reliability and efficiency of high-performance electronic systems. From data centers and high-performance computing to electric vehicles and renewable energy, thermal management determines peak performance and long-term reliability. This is Dow's Thermal Management Materials Science Laboratory. Launched in 2026, we established this global collaborative innovation platform in both Shanghai and now Auburn, Michigan on June 10th, working hand in hand with our customers to accelerate innovation and adoption. Here, we partner closely with customers to translate application needs into precise material specifications and conduct thorough material and thermal performance evaluations. Combining processability, reliability methodologies, and standardized workflows, we further complete verification at the device and module levels. Customers can directly interact with Dow's thermally conducted material samples and various electronic application test modules. They can evaluate different application methods and identify the optimal solutions for their own designs, production lines, and application scenarios. With material science as a foundation and co-creation as a path, we help customers design faster, scale production more reliably, and bring next-generation products to market more quickly.
Yes, this is where we work hand-in-hand with our customers. In our Cooling Science Studio in Shanghai and in Millen, Michigan, we start very early from concept and design with our customers. We validate the material at system level, and we co-create solution together with our customers. Because in AI infrastructure, speed matters. But speed without validation is just expensive learning. We would like to work very closely with customers, start very early, validate, and reduce rework and try error, and accelerate time to the market. As AI continues to scale, heat does not just increase, it concentrates. That's how we define the future of cooling. First, we believe that liquid cooling will become the backbone of next generation AI infrastructure. And materials like TEM and cooling fluids as two critical working together to help the system cooling will continue to evolve. And at Dow, we're working closely with our customers through the value chain partners for early co-creation. And we validate from system level where the design, the material, and operation all engineered together from day one. Because technology itself is not enough. And at the end of the day, the success is simple. High-performance materials with reliability and stability, and at a scale. Let me close with one last thought. AI continues to scale. Heat is not just a byproduct of computing. It's the limit of computing now. How we manage the heat will define how far we can go, or AI can go. At Dow, we believe cooling is not just about removing heat. It's about enabling performance. It's about ensuring reliability. And it's about unlocking the next generation AI infrastructure. And we cannot do this alone. This will require all the value chain partners in the ecosystem, our hyperscaler, our CDU, OEM, ODM, our customers. We need to co-create the solution. And I would like to invite you to our booth, discuss and explore for next generation cooling solution together. Thank you very much.